Hi, I'm Lexi Neubauer,
And I am Emily Smith.
and we had the inventory decisions problem. So to start, let's talk about the given information. First, the delivery cost was a baseline of $360 per order, and each carton cost $22.46. We were also given information of a competitor business, which had $46.90 per carton. In general, there was a holding cost of 18 cents per carton per week, which was then multiplied by the average inventory cost between orders. And finally, each truckload could carry 3,000 cartons maximum. Next, we'll talk about how we created this equation. And here are the variables that we used. So C was the cost of a carton, which you'll find out is a constant, and as well as U, which is the number of cartons the office uses per week. W is the number of weeks between deliveries, and L is the number of cartons on each truckload.
Okay, so in order to find the number of cartons used per week by the office, we can use the data from note 1, which is shown below, of the number of cartons that they used over 52 weeks. So when we take the average of this, we see that the average usage for the company is 150 cartons per week. This is defined in the equation as U, which we multiply by C, the cost of the cartons, to find the weekly total cost of the cartons.
The second part of our equation is delivery cost. So we used 360 divided by W, which represents the average weekly delivery cost. And to sum up, we are taking the total delivery cost, which is $360, which is the baseline, and dividing that by the number of weeks between each delivery that is made. So this actually helps us find out approximately how much money the company spends each week on average on delivery.
So then we needed to calculate the holding cost. In note 4, holding cost is defined to be measured as 18 cents per carton per week times the average inventory between orders. That makes the holding cost equal to 0.18 times L over 2, where L is the truckload or number of cartons on the truck on any given delivery day.
Here are our final numbers for the total cost. So to the right, you'll see just a big graph of all the numbers we tried out. These are all the different possibilities for delivery costs. And you'll see on the far right, the truck of X weeks. So each line represents a different amount of truckloads per a different type of week. So we found for an optimal delivery cost, a truckload every 5 weeks or a truckload every 5 weeks saves the company the most money, and that divides out to be about half an order per week.
So next we went ahead and graphed the results of the holding and delivery costs. So we can see that the cheapest option for the company, or the solution, can be found when the red and blue lines meet at their lowest common point, where holding cost is represented by the red line and delivery cost is represented by the blue line.
Here is just our calculation for the final total transaction cost setting. So the purchase cost is constant, so no matter how many weeks you wait per truckload, the purchase cost is the same due to a constant amount of cartons per week. So that number is $3,369 plus a $72 delivery cost, which again is 360 divided by W, which we found out for the best price is 5 weeks. And then next is $67.50 for a holding cost. It was 18 cents per carton per week. And then if you add that all up, you get our average. So We conclude that for buying 150 cartons on average per week, the company will spend approximately $3,508.50 every 5 weeks.
So finally, we wanted to see if this option would remain the cheapest if the actual cost of the cartons changed. So if we switched, or if the company switched to the local supplier or the competitor that Lexi mentioned earlier, that sells cartons at $46.90 per carton, the total transaction cost would be $7,174.50, and would still be it would still be the cheapest to get a truckload of 750 cartons every 5 weeks. So we truly believe that is the best option for the company.